Good morning. We are going to discuss the structures of metamorphic rocks. The structures of metamorphic rocks depends on the structure of the protolith rock and the conditions of pressure and temperature that prevail during metamorphism. The various structures found in metamorphic rocks are cataclastic, schistose, maculose, granulose and gneiss. So these are five types of structures, and structures, when we say, they are the different megascopic features which can be distinguished in hand specimen. So these are five structures: cataclastic, schistose, maculose, granulose and gneiss. Now in the diagram which is there, this is your the first. Let us start with the first, that is the cataclastic. Cataclastic structures are, as the name indicates, are those of broken and fragmented rocks developed by shearing stress upon hard brittle minerals in the upper zone of the earth crust. Due to shearing stress, rocks generally crush to powder. The more resistant mineral may be less crushed and may remain as pseudoporphyritic manner in fine-grained material produced by crushing of softer minerals. The structures are also known as porphyroblastics. Minerals often show marked strain effect, that is your endulose extension in quartz and the secondary twinning in calcite. A very common example of your cataclast structures, the rocks having is the crash breccia and the mylonite. This one is the cataclastic structure. This is porphyroblast. This is the same one. Now these structures, this is due to the, you can say, the stress. This fine grained matrix is there. These are the you can say the porphyritic nature, and the finer one are there, the smaller ground mass. So this is porphyroblast or cataclastic, right? And these are, as I said, are broken fragmented by shearing stress. This is mainly due to the shearing stress that are produced, and it is very common in your rock breccia and mylonite, where the shearing stress, these rocks are the result of due to the shearing stress. Now next structure is your maculose structure. In maculose, spotted appearance either due to well developed porphyroblast, that is your phenocryst of minerals like andalusite, cordierite and chlorite. Biotite in its spotted appearance as a result of incipient means incomplete recrystallization of these minerals and segregation of carbonaceous matter. That is important. There is a segregation of the carbonaceous matter. This macrostructure is typically developed in argillaceous rocks under contact or thermal metamorphism. So these two conditions means they are formed under the contact, that is your thermal metamorphism, and is of the rocks argillaceous rocks. And this maculose structure is commonly found in the rock that is your spotted shales and the hornflines. So this this one is your maculose structure. Maculose means this black one, this is the carbonaceous matter, which is the carbonaceous matter. This one is your carbonaceous. This black one is your carbonaceous matter. And similar to your maculose, these are large porphyroblasts. And these are generally of cordierite and andalusite, collotrite, biotite. Of such minerals, these are, you can say, phenocryst, and the ground mass is of the carbonaceous, and they are found by the metamorphism argillaceous rocks. Now next is your schistose. As the word says, is a foliated structure having more or less parallel bands due to abundance of parallel arrangement of flaky, lamellar, tabular or elongated minerals like mica, chlorite, hornblende or actinolite under dominant influence of directed pressure in dinothermal metamorphism. Now this is different in the sense that it is formed by the directed pressure, and it is, you can say, the parallel arrangement due to this directed stress, the minerals they get parallelly arranged in flaky, lamellar or tabular or arrangement of minerals like mica, chlorite, hornblende, actinolite under dominant influence of your directed pressure in dinothermal metamorphism. The parallel disposition of inequidimensional platy and flaky minerals in metamorphic rocks is known as foliation, and the common rock having this, because schistose is the structure is of the rock schist. So cysts are many types, say biotite cyst, hornblende cyst, biotite, hornblende, chlorite cyst, like this. So this is and common in the rocks, your cyst rocks and cysts, depending upon the mineral composition, they are of the various types of cysts. So this is, you can say here, this is your cystose. Now this one, right? This is due to our cystose structure. Cystose structure. Now this is cystose. Regarding that minerals they get parallel arrangement. Now next is your granulose. In granulose structure, due to the predominance of equidimensional minerals, means equidimensional minerals such as quartz, feldspar, pyroxene, calcite, etc. The clavial minerals or rod-like minerals are either absent or present only in subordinate amount. This is you can see in the diagram, this is your granulose, right? In the granulose means it is equidimensional grains. These grains you can see, notice these are equidimensional, and they are generally of quartz and the feldspars, pyroxenes, calcite. So there is no, you can say, the lamellar arrangement, or you can say the predominant, generally there is a predominance of the equidimensional minerals, and they don't show any, and you can say the foliation, or you can say the elongation of the mineral grains. And the granulose are therefore does not possess property of cystosity. They don't present the property of the cystosity, and the very common rocks having these granulose are your granulites, eglogites and charnokites. So this granulose structure you will notice in your rock, granulites, cystose and your charnokite rocks, and the mineral predominance is of the equidimensional minerals. You can notice here in this diagram, this is all minerals, they are all dominated by this in the rock by your equidimensional minerals, and they don't show any property of cystosity or lamination. Now next, very important is your gneiss. Gneiss structures is composite structure due to alternate cystose and granulose bands and lenticels, which are dissimilar in color, mineral composition and in texture. Means this rock will have alternate band of light and dark minerals. You can see, notice in this is a different band, this is different band, like this alternate light and dark bands. This light band is of your granulose minerals, whereas your dark, they are of the lamellar arrangement. So it is a combination of, you can say, the cystose and your gneiss structure, in which a rock is having the composite structure due to alternate cystose and granulose bands and lenticels, which are dissimilar, as I said, in color, mineral composition and texture. The granular aggregate are of minerals like quartz and feldspar, means these light colored minerals naturally, are of quartz and feldspar, and lamellar minerals are like your hornblende and your mica. This is, you can say, the structure. Gneiss is the advanced condition of schistose structure, and there's, you can, gneiss and the common rocks having these gneiss we call as the banded gneiss and organ gneiss. So it is very common in rock or gneiss, you can say, in general. So this gneiss structure is an advanced structure of the schistose, and in which there is an alternate arrangement of your light and dark minerals. Light minerals, they are generally equidimensional, whereas your dark minerals, they are laminar of arrangement of hornblende and mica, whereas in light there is minerals like quartz and feldspars, and there is an alternate band of these quartz and feldspar, and it is very common in your gneiss. So this is all the 5 types of your structures which are common structures in metamorphic rocks, and they are formed by the different, you can say, PT conditions that prevailed, and also on the, that depends upon the pre-existing rock which has gone under metamorphose. To that rock we call that the protolith. So it depends upon the structure of that protolith rock as well as on the conditions of metamorphism. These 5 structures are found in metamorphic rocks. Thank you very much.